Critical values are those values which are going to lead you to reject a null hypothesis in favor of the alternative hypothesis. And when considering critical values, there's three things that you need to look at. First of all, you need to look at whether or not you're dealing with large or small samples. You need to look at whether or not you're dealing with a directional or non-directional alternative. And you have to consider what the alpha level is for the test. So in these particular examples, if you just methodically go through those steps, you can figure out what the critical value is. For example, number one, you have a large sample, which implies you have a z as a comparative distribution. Your alternative hypothesis is non-directional, which means it's greater than or less than some value. So that means you're going to have two rejection areas, positive and negative scores. And the alpha level of 0.05 means for a z-test that you basically divide that in half, look at that point at which 0.025% of the cases fall between that point and more extreme than that point. And if you look at the table normal curve, you'll find that value is 1.96. So because you have two rejection areas, the value is plus or minus 1.96. In the second example, you have a large sample, again a z, a directional alternative hypothesis greater than 0.05 alpha. So you look in column C for an alpha 0.0 or a area that corresponds to 0.05, you find that area to be 1.64 because you're dealing with a positive greater than alternative hypothesis. That means your z-score is 1.64. In the third example, the same thing, except now the alternative is less than, and therefore it's a negative z-score. In the fourth example, you've got a small sample. So you look at the table of Appendix B on T-table, and what you find is for a 0.05 level at 24 degrees of freedom, you find the critical value is 2.49.